Now, when you talk about electrical energy, this energy can get converted into light energy. When you use it to light a bulb, it can get converted into heat energy if you're using it in a toaster, oven, geyser. It can also be used as a mechanical energy if it is used in fan, motors, and so on. It can be used as sound energy if we use speakers. Then you can have magnetic energy. Okay, current passed through a solenoid produces a magnetic field. Then so you can convert this into so many different forms of energy. Examples of that we have studied earlier in the chapter work, energy, power as well. Okay, so another is also chemical energy when we are using charging of a battery. So an electrical energy does get converted into so many forms. Now, when you talk about energy, we always say that the work done gets converted in the form of energy. And we have seen the definition of potential. So V is equal to W by Q. So if there are 2 points A and B, and they have a potential difference of V, and you are taking a charge Q from that point B to A, then the work done by you is W, then all these three are related by this formula. So when you talk about electrical energy, we can say that W is equal to V into Q. Okay, so that can be termed as one of the equations. Now, the second thing, whatever we are using, I'm just going to write it in green over here. We know electrical current is rate of flow of charge. So therefore, Q can be replaced as I into T. So over here, W will get equal to. So I can write over here. So W is equal to V into I into T. So that's another equation for me. We also know Ohm's law. It says V is equal to I into R. So if I substitute that over here, so V is substituted as I into R. So that gets I square RT. Okay, so that's another form. Now, instead of substituting V is equal to IR, I can substitute I as V by R. So what do we get over here? So V, and this is V by R into T. So you get V square by R. That's number 4. Okay, V square by R into T. Now all these equations that I have written over here will be useful for solving questions. Especially, when you talk about I square RT, and over here, let's take one very good example. So let's say that this is a cylinder, and this cylinder is filled with water. Okay, so here we have you have water filled in over here, right? And we are allowing current to flow through it. Okay, so there is a resistor, and there is, and you can say that you have like a rheostat. Yeah, so this is a resistor R. You can have a thermometer that can measure the temperature, and the rise in the mercury will tell you the heat that is taken. So over here, work which can be converted into heat energy. Okay, so the geyser that we have in the bathroom, which is making the water hot, does have a resistor like this inside it. So that resistor heats up the water. So here what we see is if you allow the water, means if you keep it on for a longer time, the water does get heated. Okay, so that talks about T. That means more time you allow the current to flow, more will be the heat. Heat will be proportional to resistance. That means if the value of the resistance that is in this, if you increase it, more heat will be produced. Okay, something that we can't do in our house. We can only control the time for which the current is flowing. And the second is I squared. Okay, so here H is equal to I squared. Now how can you control current in this circuit? You have a rheostat. So with the help of a rheostat, if you reduce the resistance in the rheostat, you can allow a stronger current to flow. If you increase the resistance in the rheostat, you will allow lesser current to flow. And it is observed that if the current increases, you make the current double, then the heat will become 4 times. Okay, so it is observed that the heat will be 4 times. Okay, so so this is the relation, okay, between heat and current. And that is the reason why in the household electricity chapter, you will study that the voltage is increased so that the current reduces, because if the current is less, the heat dissipated will be less. Okay, so this is an important formula. So just let's write this down. V is equal to V into I into T. It is equal to I square RT equal to V square upon R into T. Fine. Okay, then we move to this power. So power we know is work upon time. So this is all about work and energy. So if you divide by T throughout, we are going to get P as V into I square R, and V square by R. So these are all the terms for electrical power. So therefore we can define it. P is equal to VI. Power will be 1 watt if you have 1 volt, and this is 1 ampere. Okay, so 1 watt will be the electrical power if there is a potential difference of 1 volt and a current of 1 ampere flows through it. So that can be asked like a definition. Okay, don't miss that part. And few things which we have done earlier in the work energy chapter, which will get repeated over here. That is 1 kilowatt is 1,000 watt. Okay, 1 megawatt is 10 to the power 6 watt. 1 gigawatt will be 10 to the power 9 watt. Then 1 kilowatt hour is 3.6 into 10 to the power 6 joules. Okay, this is an important relation, right? Okay, also with this relation, we have something called as power rating of an appliance. Okay, so generally you will notice that the information of the appliance is given like this. Okay, so there is oven which is rated 1200 watt to 20 volt. So what does that mean? It means that when the oven is connected to 220 volt, it consumes 1200 watt of power. So that is how you determine. And what else can you do with this information? Okay, very important information will tell you that power is equal to V into I. Of course, it will tell you that it takes that much power. So if you have another oven which is like 1000 watt and 220 volt and everything else is same, so that means this oven is better. It is consuming lesser energy. So this is 1200. This is 220 into I. So that will be 1200 upon 220. Okay. So this value 120 divided by 22, which will be 5.45 amps. Now this will tell you how much current will flow through this oven. And therefore you can decide on the fuse wire that you need for this instrument. So that is the importance of this power rating. Okay, so far any questions? Okay, so what we can do is we can do a few numericals now. An electric bulb of resistance 500 ohms and the current flowing in it is 0.4 amperes. You have to calculate the power and you have to calculate the potential. Okay, so how will you calculate power? Power, if you look up at this formulas, it is I square R. So this will be I square into R. So 0.4 squared into 500. So that will be 0.16. And that answer will be 80 watt. The second part is they want V. Okay, so V is equal to IR, Ohm's law, simple. So 0.4 multiplied by 500. So that will be 200 volt. Okay. Now the next thing is question number 2. A current is 2 amperes. So I is 2 amperes. Resistance is 75 ohms. And time is 2 minutes. Okay, that is 2 into 60, that is 120 seconds. How much heat is produced? So heat they want. And the charge. So H is equal to I square RT. That is 2 squared into 75 into 120. So that is 4 into 75 into 120. So this will be 36000, okay, joules, and 1, 2, 3, 4. So 3.6 into 10 to the power 4 joules. Right. For the second one, you have I is Q by T. So 2 is equal to Q upon time is 120. So that is 240 coulombs. That will be the charge. Okay. Okay. Question number 8. There is an electrical appliance having a resistance of 200 ohms. So resistance is 200 ohms and the voltage is 200 volt. Calculate the energy consumed by the appliance in 5 minutes. So time is equal to 5 minutes. Now, what I want you to understand over here is very important, that energy is equal to power into time. Okay. Now, if you calculate the power in watt and time in seconds, then this will be joule. But if you substitute the power in kilowatt and time in hours, so then it is simple, kilowatt hour. So here, if you have electrical energy, that is power into time, and they have given us, they don't have power, but we can use that because energy, we have this formula over here, V square upon R into T. So let's do that. V square upon R into T. So that is 200 and 200, and R is 200. Okay. And time is 5 minutes. So that is 5 into 60. This whole thing get cancelled. And 5 into 2 will be, this will be 1000 and this will be 60. 1, 2, 3, 4. So 6 into 10 to the power 4 joules will be the energy. Now, if you want to do it in kilowatt hours, you know that 1 kilowatt hour is 3.6 into 10 to the power 6 joules. So how many kilowatt hour will be 6 into 10 to the power 4 joules? So this, I don't think it's a difficult math for you. So H will be equal to 6 into 10 to the power 4, and this is 3.6 into 10 to the power 6. What can you do over here? 6 into 10 to the power 4, 36 into 10 to the power 5. So 6 ones are 6 six are. This is 1 by 6, and this is minus 1. So this is 0. If you divide 1 by 6, you'll get 167, and you have a 10 to the power minus 1. So 1.67 into 10 to the power minus 2 kilowatt hour. That will be your answer. Okay. Any questions in this? Then we'll do number 11. Okay, question number 11. What is the resistance under normal working condition of a electric lamp? So which is given 240 volt and 60 watt. So you pick up a lamp, and on the packet it is written that 240 volt 60 watt. That means when you allow 240 volt to flow through this lamp, it will consume 60 watt of power. They are asking that, can you use this information to calculate resistance? The answer is yes. P is V square by R. So R is V square by P. So here you have 240 into 240 upon 60. 6 fours are 0, 4 fours are 16, 9. So this will be 960 ohms. So that will be the resistance. Okay. Now just imagine that this is a lamp, and here you have a power supply. It doesn't matter whether it is alternating or direct. It says 240 volt. So what will be the current? We know P is equal to V into I. So this is 60. This is 240 into I. So I will be 60 upon 240. 1 by 4. 0.25 ampere will be the current flowing through the lamp. Okay, and the lamp will glow. Now the second part of the question says that two such lamps are connected in series. Okay. Now two such lamps are connected in series. Now this is your understanding now. So do you think that 0.25 ampere will flow? Yes, anyone would like to answer this? Okay, the question is again, this was single bulb or lamp, and it was connected to 240 volt. Now there are two lamps. So 240 volt is not individually across each. 240 is across both of them. Okay, so that's the problem. And the resistance also is 960 plus 960. Okay, so that will be how much? 1920 ohms. So in this case, if you do P is equal to V into I, we want to know the current that is flowing. Our current is V is equal to IR, we can do. So 240 is I and 1920. So 240 upon 1920. The answer will be 1.125 amperes. Okay, so what is happening over here is because you have added to the resistance compared to the first part. Now the current flowing is 0.125 amperes, which is half the current that was flowing over here. So the bulb will glow, but it will glow less bright. Okay, so the bulb will glow, but they will glow less bright. And the reason for that is since the resistance has doubled and the current is half, the bulb, the lamp will glow less bright. Okay, so that's the answer to that question number 11, right? Okay, fine. Now we will do one question, which is number 19. Okay, the electrical toaster draws 8 ampere current. So that's the current it draws. And the voltage source is 220 volt. Okay, and it is used for 2 hours. Okay, it is used for 2 hours. So they are asking us the cost, and it is given that the rate is rupees 4.50 for 1 kilowatt hour. Okay, so I want to know the number of kilowatt hours consumed over here. So we know that the energy, okay, is I square RT. So this is 8 into 8 into 220. Wait, we don't have R. So we have V. So we know that power is equal to V into I. So power into time. So this is 220 into 8. If I divide this by 1000, I will get kilowatt. And the time is 2 hours. That's already given. Okay. So this will be 222 into 8. So that will be 3.52 kilowatt hour. That will be the energy. Okay. And cost will be 3.52 multiplied by 4.50. That will be rupees 1584. That's the answer. Okay. This will be 15.84. Sorry, that will be the cost of running. Let me take you a very simple question. Okay. On page number 206, on page 206, they have given us a table. So it says that the fluorescent tube has a power wattage of 40 watts. So say for example, there is in your house or in a room, there are two tube lights, okay, and they are operated for 8 hours per day. There is one fan which is operated for 12 hours per day. Now, if you are using this for a month, okay, now 1 month, whenever they say 1 month, you have to take 30 days. If it is used for 30 days, what will be the bill, electricity bill, taking into account the same thing, okay? So, two tube lights, each consuming 40 watt and for 8 hours. So that will be 2 into 40 into 8. So that will be 2 into 40 into 8. That will be 640 kilowatt, watt hour. Then you have one fan. In the table they have given for the fan 60 to 100, we'll take it as 100 into 12. So that will be 1200 watt hour. If I add them, I get 1840 watt hour. Or I can say 1.84 kilowatt hour per day. Now we need it for the month. Okay, so what will be it? So for 1 month, it will be 1.84 into 30. So that will be 55.2 kilowatt hour. Okay, and now we need the cost. So that is 55.2 multiplied by 4.50. That will give me rupees 248.40. So that's also a very important type of question that can be asked.